is the difference between fissile and fissionable? It just comes down to the type of neutron that's required to induce fission. Now, when I have fission, I will generally kick off 2 or 3 neutrons, something like that, and they will have, say, 2 or 3 MeV of energy. Now, if I have a 1 MeV neutron, within a fraction of a microsecond, it's going to give off most of that kinetic energy just from banging into other nuclides that are in its environment. And when that happens, eventually it's going to have such a small amount of kinetic energy that it can be upscattered in energy with the same probability as being downscattered in energy as it's ricocheting off of these other atoms. See, these atoms are vibrating with their heat and they can upscatter or they can also absorb energy. So a thermal neutron is what's required for a fissile nuclide to fission. All fissile nuclides will fission if they have a thermal neutron. Now, that would be, for example, uranium-235, uranium-233, or plutonium-239. Fissionable is usually a fertile isotope, meaning that if it absorbs a neutron, it can decay into something that would be fissile. But a fissionable just means that I need basically a 2 MeV neutron to hit into it. The cross-section, the probability of fission is basically like a step function. It's almost zero all the way up until you get to, say, 1 or 2 MeV, where the probability starts to increase. So you can fission uranium-238 with a really, really fast neutron, or thorium-232. You can fission that with a really, really fast neutron. So it's fissionable, but it's not fissile. In other words, it's not going to fission with a thermal neutron. It will only fission with a fast neutron. And there are a lot of actinides that are like that. Pretty much all of the actinides. If you get a high enough neutron, any actinide will split up. But now we're talking, many, many tens of MeV, and then, yeah, you can pretty much knock anything apart at that point. So, great question. Thanks for asking it. Have a good day.